Longevity is having a moment, biological age tests, Ozempic for aging, billionaires trying to reverse the clock. Behind all the hype is real, fascinating science. We now understand aging not as a mystery, but as a set of specific, measurable biological processes. This series cuts through the noise with the evidence. A quick note first, this is educational, not medical advice. Today, the foundation, why we actually age. Let's start by reframing what aging even is. It's tempting to think of aging as a clock counting down, or a single program that switches on. But that's not what the science shows. Aging is better understood as the slow accumulation of molecular and cellular damage over your entire lifetime. Your cells are constantly being injured, by the byproducts of metabolism, by radiation, by the ordinary wear of copying DNA billions of times, and while your body repairs most of it, a little slips through every day and builds up. For decades, that damage stays below the threshold where you'd notice. But eventually it crosses a line, tissues start to fail, and you get the diseases of aging. This is why age itself is the single biggest risk factor for heart disease, cancer, dementia, and nearly everything else. Here's the breakthrough that organized the whole field. In 2013, a group of scientists published a landmark paper that took the messy biology of aging and sorted it into a clean set of distinct processes, the hallmarks of aging. The list was updated in 2023 to 12 hallmarks. Why does this matter so much? Because it turned aging from a vague, single mystery into a list of specific, concrete mechanisms, and a specific mechanism is something you can potentially target. Each hallmark is a possible lever, something a drug or a lifestyle change might slow down, repair, or even reverse. Almost every longevity intervention you'll hear about in this series, from rapamycin to fasting to the new drugs, works by targeting one or more of these 12 hallmarks. So they're worth knowing. You don't need to memorize all 12, but it helps to see them grouped. The first group is damage to the cell's core machinery, instability in the DNA itself, the shortening of protective caps on our chromosomes called telomeres, chemical changes to how genes are switched on and off, and the buildup of misfolded proteins. The second group is the cell's own maintenance systems breaking down, the sensors that track nutrients getting stuck in the wrong mode, the mitochondria, the cell's power plants, becoming inefficient, and the cellular cleanup crews slowing down. And the third group is the wider, system-level problems, cells that stop dividing but refuse to die, called senescent cells, which we'll cover next episode, the exhaustion of the stem cells that replenish our tissues, a slow, chronic background of inflammation, and even imbalances in the gut microbiome. 12 interconnected processes, all pushing in the same direction. Here's why this framework is genuinely hopeful rather than grim. Because the hallmarks are all interconnected, pushing on one often improves several others, inflammation, nutrient sensing, and senescence all feed into each other, so a single good intervention can ripple outward. And crucially, many of these hallmarks respond to things we can actually influence, from exercise to specific drugs now in human trials. It's also important to be clear about the real goal, because the hype gets this wrong. Serious longevity science is not chasing immortality or living to 200. The realistic, evidence-based goal is extending health span, the number of years you live in good health, free of disease and disability, rather than just adding frail years at the end. Compressing the sick years, not just stretching the lifespan. That's the honest and genuinely achievable target. So the takeaway that sets up this whole series is this: aging is no longer a black box. It's 12 specific, measurable biological processes, each one a potential target for slowing or reversing the damage. That's a profound shift. It's what turned anti-aging from science fiction into an actual field of medicine with drugs in human trials. Over the rest of this series, we'll take the big hallmarks and the big interventions one at a time: senescent cells, the epigenetic clock, telomeres, rapamycin, metformin, fasting, exercise, and the surprising role of the new weight loss drugs. And every single time, we'll ask the one question that separates science from snake oil: what does the evidence actually show? Because in this field, that question matters more than anywhere else. This is educational, not medical advice.